Hello, RGL 3300 students. Dr. Conway here, back for lesson 4 on product risk assessment, the role of science. There's just some key concepts I want to go over. In this program, as in most Algonquin College graduate certificate programs, students need to see prominent topics at least 3 times, preferably in 3 different courses. So some of this you will know about, but I want to flag some of the key points related to why they impact post-market surveillance. Okay, don't forget we have our Zoom call on Tuesday at 4 o'clock, where you can pick up any questions you have about your term papers part 1 and any questions related to the lecture. Okay, so let's start off with talking about this particular process right now. Okay. The challenges of monitoring depiction of Canada's National Chemicals Management Plan. You can see this slide, which kind of gives us a good overview of what goes on in sort of risk assessment and risk management of hazardous chemicals. Risk assessment is a lot of what you've been learning about in some of your other courses, where we assess a product for the risk it poses before it's given a license or a registration to enter the Canadian market. That we know a lot about from our other courses. Okay, but then what we shift into is a risk management phase, where we once we've established the risk profile of a hazardous product, if we're going to allow it to come onto the market, we have various risk management activities that we have to participate in as governments and as corporations, meaning that just because a product has been approved by a market, it's been approved for the market based on certain assumptions about how the ongoing risk related to that product is going to be managed, right, in the marketplace. How it must be transported, stored, used, what information has to travel with it. All of those aspects, including post-market surveillance of what happens to the product once it's on the market, all fit into that category of risk management. All right, risk assessment before it enters the market. Okay, and then yes, we do risk assessment after it enters the market, when we do reviews, when we do reassessments of products like pesticides or whatever. We're returning back to the risk assessment cycle. But once a product's been approved for the market, it falls into a risk management set of activities that we're working that we want to manage. Okay, a key component of that, of course, is compliance, promotion, and enforcement of the existing regulation with respect to a class of chemicals. All right. And so we set up a lot of a risk management framework. Then we apply a compliance, promotion, and enforcement to that risk management framework. In other words, we ensure that if we say that this compound can only be shipped in this manner, we do compliance, promotion, and enforcement to ensure that in fact it is only being shipped according to that aspect of the risk management framework. All right, and post-market surveillance is primarily doing an aspect of that risk management and that compliance, promotion, and enforcement aspect of that. All right. Then when we get onto the other side, we have research and monitoring, and that's the ongoing activities that governments will do to determine whether, out of our risk management, compliance, promotion, and enforcement activities, we're finding any significant outliers with respect to things not behaving the way we thought they were going to behave. That we're finding more chemicals in the environment than we thought we were going to get. That the pesticides are causing more harm to birds or to pollinators than we thought was going to be the case. That we're getting fish die-offs or whatever the case may be. Research and monitoring can influence or inform us how well our risk management, compliance, promotion, and enforcement activities are in fact working, and then that can feed back into risk assessment when that product comes up for review later on. Okay, so we know that, seen that way, we can say that management of hazardous chemical products basically has 2 large clumps to it: risk assessment and risk management, of which I will include compliance, promotion, and enforcement, and ongoing monitoring. All right. Risk assessment determines the probability that some negative event happens based on the hazard properties, proposed uses, possible uses, and anticipated exposures for the chemical. Why are all these concepts important? Because as we get further into how various classes of chemicals are assessed, We know that industrial chemicals are different than what we get with pesticides and different than what we get with pharmaceuticals. When we assess industrial chemicals, we're asking not only about the hazardous properties, but we're asking about the proposed uses, possible uses, and anticipated exposures for the chemical. For example, an industrial chemical can be approved for these specific uses at this specific level. Okay? If a use of that chemical changes or a new use of that chemical emerges, then a reassessment of the safety of that chemical may be necessary. All right? But regardless of how well we do in assessing any chemical, we know that there will still be residual risk. Okay? There's always residual risk. When you're trying to capture the benefits of a hazardous chemical, you're trying to reduce the risk to a reasonable level before you allow it on the market. But there will always be residual risk, just as there are always side effects for pharmaceutical drugs, or there are potential risks related to pesticides. There are potential risks related to industrial chemicals. We know that when we approve it for the market. But we think that our assessment has given us enough guidance for risk management that if we apply the risk management properly, the level of risk will be acceptable. What post-market surveillance tries to determine is that true? Is the residual risk continuing to be justified or allowable, or are we exceeding those risk profiles of what we anticipated to be the residual risk? And that's when you get into things like recalls and these kinds of things, because we found out through our post-market surveillance activities or through our monitoring activities and so on that the residual risk was greater than we thought when we approved the chemical. So therefore, we might have to do something about it. We might have to pull it off the market completely, or we may have to insist upon an advisory or new labeling requirements or more restricted use, or whatever the case may be. Okay? So that risk, that residual risk, is kept under constant review in post-market surveillance. Okay? So residual risk is defined as the threat that remains after every effort has been made to identify and eliminate risks in a given situation. Now, as we all learned from last term, you never completely eliminate all risk, right? You can spend $1 billion eliminating 80% of the risk and another $10 billion eliminating the final 20% if you want to capture all the benefits of the product. That's not feasible. So we try to capture the benefits of the product, eliminating all risk that can reasonably eliminated while still making the product a viable prospect to capture its benefits in the marketplace. But because of that, there will always be residual risk, and that's what we're monitoring when we do post-market surveillance. The threat is defined as the degree of exposure to a potential hazard even after that hazard has been identified and agreed upon mitigation has been implemented. So even if we do everything we said out of the risk assessment, in terms of the risk management framework, in terms of the compliance promotion, in terms of the monitoring and so on, there's still residual risk. So we need to surveil that residual risk. The residual risk is calculated in the same way as the initial risk by determining the likelihood and consequence and then combining them in a risk characterization. Okay? Risk management seeks to mitigate risk through the development and implementation of a regulation or another type of policy instrument to control the risk. All right? For example, we've allowed a hazardous chemical on the market, but we need to control the risk that it poses when it's transported. So we'll have a series of regulations about who can transport these things. What type of technical equipment do they need? What type of training do the drivers need? All those things are risk management strategies to ensure that the risk profile of that chemical product is respected in the marketplace so that unnecessary risk is controlled or mitigated. And we can modify these risk management requirements at the risk assessment stage. Not every chemical that's approved for the market gets the same risk management treatment. Some particularly hazardous compounds, for example, get much stricter risk management controls than, for example, a cleaning agent you would use in the household. Compare a cleaning agent used in the household to, say, chemotherapy drugs, for example. Obviously, the risk management regime for the latter is much stricter than the risk management regime for the former. The post-market surveillance regime for the latter is also more strict than it is for the former because the hazard posed is quite a bit different, exponentially different, okay? And so risk management looks at these things on a continual basis, And part of that, as I said, is post-market surveillance. And there are three basic ways you can deal with residual risk, right? You can reduce it through stricter risk management initiatives. You can avoid it by not allowing the compound on the market at all, okay? Because you don't think that even though this compound can have benefits, if we release it to the market, we still think the risks are too high relative to the benefits, and we're just going to avoid it entirely. We're not going to allow it on the market. Or there's other ways to avoid it, right? There's whole classes of circumstances where you just simply can't, even though there could be a beneficial use in some industries, you simply just do not allow it for use in those industries because they cannot institute the risk management framework in the same way, say, another industry can. For example, we allow plutonium in a highly regulated nuclear power industry, but we wouldn't allow plutonium to be used in an industry that's not set up for that kind of risk management. It's simply not permitted, okay? Or we can accept the risk. Sometimes, you accept the risk in such a way. For pesticides are an example. We know that pesticides released to the environment can be a substantial risk, but we accept that risk to a certain degree because of the impact that it can have on improving food yields and dealing with food shortages and things like that, okay? Or in the case of DDT, we knew DDT can cause a lot of harm over the years, but we allowed DDT to continue to be used under the Stockholm Convention because the alternative was worse, which was uncontrolled malaria or dengue fever. Okay, so there are different examples, different calculations you would make for this kind of things, okay? And we all know, as I'm saying, that we do a pre-market assessment. I'm not going to go into these slides, but you have them. I'm not going to go into them in a great deal of detail, but I want to flag these because you can see where the residual risk becomes a factor and has to be monitored continuously. We know that the key risk of most of the chemicals we deal with is toxicity, right? And how long that toxicity can persist in the environment because of persistence and its impact on bioaccumulation. But if we focus on toxicity, we assess these chemicals for toxicity given their anticipated uses, at what volume, by who, where, and so on. And we try to say that, is this particular use for this compound beneficial enough to justify that we're going to set up a risk management regime for it and accept a certain amount of residual risk, okay? You've probably already learned about the concept of the Red Book. Red Book 1983 was the main book that set out the methodology for toxicity assessments. And to this day, the core concepts set out in that book are still valid, okay, with all their limitations, all right? We'll talk about limitations as we go through the course, okay? There are four concepts that remain at the core of risk assessment. You've known it, you probably have studied in your other courses. One is hazard identification. Determines whether exposure to a particular chemical agent has the potential to produce adverse health effects in humans. Now, this is not necessarily an exact science, okay? Because we can have exposures to chemicals that will impact different communities in different ways. We can have different types of exposures that can magnify the hazard, the characteristic of the compound. We have a whole bunch of circumstances that can intercede in that understanding of, the exposure, the hazard exposure that could invoke a negative response. And so there's residual risk left even at that level, okay, that we need to monitor in post-market surveillance, okay? Then we do dose response assessment, okay? We know that. These are general classes, right? There are different tests for different chemicals under each of these classes, but I'm trying to set out the logic as to why we need to do post-market surveillance. Dose response assessment determines the relationship between the adverse effects and the dose of the chemical agent. In other words, we can use it in this way by this much only in order to be able to keep the risk threshold to a level that we can tolerate or that we can accept. But obviously that's going to be a very variable situation as well, depending upon whether a person is exposed to other types of chemicals, their age, whether they're pregnant, not pregnant, male, female, children, full-grown male, adult, all the different the differences that can occur to the dose response assessment, there's bound to be a lot of residual risk left in that. There's only so many variables that the risk assessment process can assess with any kind of detail, that there's always going to be uncertainty, which we will call that uncertainty residual risk. Okay? The exposure assessment tries to map, well, how would people be exposed to this in ways that could be harmful and not beneficial? And that will look at various scenarios for frequency and duration of exposure, okay? But as you can see, that there's so many factors that are moving parts when you do an exposure assessment. The wind, the weather, whether it's a farmer or whether someone just lives near a farm, whether it's a woman, whether it's a man. All those exposure assessments, occupational exposures as opposed to general population exposures, northern exposures as opposed to southern exposures. All those different types of occupational and other exposures need to be assessed for that chemical. And obviously, there's no way that you're going to be able to cover off all of those possible scenarios. The system, even if they run 100 different tests, there's going to be a bunch of scenarios that those tests will not be able to anticipate, okay? And that's why post-market surveillance regimes are constantly assessing whether that residual risk is true. Is there a new use for the chemical that emerged once we approved the chemical? And all of a sudden, because there's a completely new use in a new industry, the exposures have changed completely. There's new kinds of exposure, okay? So that becomes part of the residual risk. Risk characterization estimates the risk of negative health effects under the conditions determined in the exposure assessment, okay? Uses the information from the dose response assessment and the exposure assessment to characterize risk. Is this an acceptable threshold of risk? Given all of our assumptions in dose response and exposure assessment, is this an acceptable risk? But we already determined that dose response and exposure assessment, they can have their own residual risk embedded in that. Now we have a risk characterization that sets a threshold, right? A threshold of an acceptable risk. Science can tell you what that risk is to a degree. As I've already said, there are limitations to science even in the previous categories. But here, we're also setting a threshold that science can tell you what the risk is, but science can't tell you whether that risk is acceptable to you or to society or not. Okay, that's a value judgment. All right, are the benefits worth the risk? That's a value judgment. In some societies, absolutely, it's worth the risk, right? In Canadian society, much more cautious about risk. In some other societies like the Nordics or like Sweden or Switzerland, these kinds of things, they might have even lower risk thresholds. So risk is a value judgment. It adopts an assumption that there is going to be a certain amount of residual risk. How much we're willing to accept largely is culturally and socially accepted, okay? And so, and look through, the book, Science and Decisions, Advancing Risk Assessment, that book that I flag here too, for 2009. And you can see some of these things emerging through that, okay? And here's a simple diagram on toxicity testing and risk assessment, all right? I'm not going to go into that in any detail. You have the slide, okay? Risk characterization and risk management phase, I described those two in this slide, all right? So I want you to realize all the areas that when we go through risk assessment and we go through setting up the risk management framework and so on, all the areas where, it's not possible, okay? Science can do a lot, but it's not possible for science to be able to tell us in detail all the different scenarios that hazardous chemical. And this is when risk assessment framework doesn't even consider, okay, mixtures in the environment, okay, where you're exposed to not one chemical, but maybe dozens. And how do they interact in your body? How do they interact in the ecosystem? There's so many factors that science and risk assessment can't tell us. It can tell us a lot, but it can't tell us a lot of things, and that poses residual risk. So we must constantly be asking ourselves, how well are we at monitoring residual risk through post-market surveillance? How effective are we? There are still lots of gaps, that have to be addressed because we don't address mixtures in the environment, okay? How closely do we monitor alternative uses, okay? Or mixtures, people mixing chemicals together, or using them not strictly in ways that they should, all right? All of these factors become part of the residual risk matrix, and they're things that have to be post-market, they have to be surveilled in a post-market kind of way, all right? So keep this stuff in mind as we go through. I'll talk to you tomorrow on our Zoom call, and we can pick up any questions about this or any questions about your term project part 1. Okay? Have a good day, gang. Talk to you a little bit later. Bye-bye now.